This video lesson is about how to add and subtract rational expressions. Here's the procedure for how to do that. You've got to start by factoring the denominators of all of the rational expressions that you're adding or subtracting. You'll state the restrictions, find a common denominator, because rational expressions are just fractions, and to add or subtract fractions, you have to have a common denominator. You'll figure out what missing factors you have to multiply each rational expression to get that common denominator, and then simplify numerators and reduce your final answer if possible. I'll show you what I mean. In this first example, there are two rational expressions that I'm subtracting. So the first thing to do is to see if we can factor the denominators. In this case, because they're both monomials, they're not factorable. So I move on to step 2, which is stating restrictions. The restrictions are whatever values make the denominator 0. Here there's no value that can make 25 equal to 0. But 15a can be 0 if a is 0. 15 times 0 is 0. So that's my only restriction here. Next, finding the common denominator is finding a common denominator between 25, 15, and a, all of the factors in the denominator. So numerically, I'll find a common denominator between 25 and 15. That's 75. And because there is an a, my final common denominator will have to have an a as well. Now, to figure out what to multiply each factor, or each rational expression, to end up with that common denominator, what I'm asking is, what do I need to multiply this, top and bottom, to make sure that I end up with a denominator of 75a? Basically, what do I have to multiply 25 by to get 75a? And that answer is 3 and a. I'll multiply this through 3a times 2a. And then at the bottom, I'll get 75a as my denominator. And here I have to do the same thing. This one already has an a in it, so I've only got to multiply the top and the bottom by 5. And when I expand, brackets are important because this 5 is multiplying this entire expression. I have to distribute it to the a and to the negative 3. And when I do that, one thing that you have to be very careful of is that once this is distributed, and remember when I multiply monomials, I multiply their coefficients and I add exponents, this minus distributes. You have to remember, so I keep this in brackets all the time as a reminder that I have to distribute any negative that's there. It means it's going to be minus 5a and plus 15. And if this was factorable, I should factor it, but in this case it isn't. So I add my restricted value in, and that's my answer. If instead of having monomial denominators, if I had binomials, I would again check to see if anything was factorable. In this case, they're not. There are no common factors. Neither one is a difference of squares. That's all I have to look for binomials. So I'll skip ahead to the next step, which is finding the restrictions. And what I wrote here was that I write them in brackets to keep track of the fact that that entire thing is a factor, just to avoid making errors of trying to cancel out either just the x or just the constant term. So again, my restricted values are what would make each one of these expressions 0, and as a trick, you can set that value equal to 0 and solve. This one gives you a value of negative 5 over 2, this one negative 1. Those are my two restrictions. And I move on to finding a common denominator. In the case that you have two factors in the denominator that don't have any common factors themselves, the common denominator will be the product of those factors, meaning that I've got to multiply this entire expression by x plus 1 and this one by 2x plus 5. My common denominator is the product of the two denominators. Same. So I've got to multiply each one by the missing factor. I've got to multiply this one by this guy's denominator, and then this one by this guy's denominator. And again, that minus is going to apply to this entire thing. So I should do this double distribution first. So that step of simplifying the numerator is just expanding, distributing this negative sign after I've done this double distribution, and then grouping like terms. My restricted values stay there. And again, if this was factorable, I should factor it because maybe something will cancel out. But in this case, it's not. That's the most simplified it gets. So this one here, I'll show you this one, and then the next one you can try on your own. If I have a trinomial, or anything higher than that, I guess, you should try to factor it, and probably it is going to be factorable. And in this case, both of these denominators are factorable. Step 1 was to factor. So I'm factoring this trinomial and this one. If you want to pause for a minute and try it on your own, now would be a good time. I'll skip ahead to show what those factors are. This one factors as p minus 4 times 2p plus 5, and this one is p plus 2 times 2p plus 5. So there's a common factor there already. The next step is to state restrictions, so that's based on each one of these factors. 4 is a restricted value, negative 5 over 2, and negative 2. This one was already mentioned. So those are all of my restrictions. Probably I should have written them in increasing numerical order. I didn't here, so it's not bad. The next step is to find the common denominator. And if there is a repeated factor, this one already applies. So the only one that's missing from here is this p plus 2. And the only one that's missing from here is the p minus 4. So that's going to be my common denominator. It's one of each of the denominator factors. So that one's a repeated one. And to end up with my simplified numerator, I will have to multiply this 3 by the missing term, the one that was missing. That's this one. This one didn't appear in this rational expression, so I've got to multiply it. That's how I ended up with the common denominator, multiplying the top and the bottom by p plus 2. And here I would have had to have multiplied the top and the bottom, numerator, denominator, by p minus 4. So I'll have to multiply this by p minus 4, the missing factor. I'll expand, I'll group like terms, and if, again, this was factorable, I should factor it. Here it isn't. So a slightly more complicated example, if you want to pause for a minute and give it a try, this would be a really good challenge. I'll just skip ahead and show you the answer. Factor each trinomial. There are some repeated factors here, like these both have an x plus 5, these both have an x minus 4, and these both have an x plus 1. In terms of my restricted values, those will be all of the factors that affect that. This one was in numerical order. You nailed it. And to get the common denominator, it's going to be one of each of the different factors. So this one here was only missing an x plus 1. I'd have to multiply top and bottom by x plus 1. That's what goes in there. This one was missing the x minus 4. And multiply top and bottom by x minus 4. And this one was missing the x plus 5. So again, distribute, group like terms. That's my final answer. If this was factorable, you should factor it. That's all there is to it.